All right, so I'm going to be doing some videos on different ones from the study guide for Unit 3. I skipped over 1 and 2 because I feel that you should have those in your notes already. So I'm going to number 3 first. Is finding the exact value of each expression, and you need to use the unit circle. So I have the unit circle to the right. You just have to remember that on the unit circle, cosine is always the x-coordinate, sine is the y-coordinate, and tangent is taking the y and dividing it by x. So for the first one here, we want to find the sine of 630 degrees. Well, we need to figure out where that's going to land on the unit circle. It is going to be passing a full circle, and then how much more past 360? If I do 630 minus 360, I get 270 degrees. So the sine of 630 lands on 270 here. This got chopped off. There should be 0, negative 1 to point down there. So the sine of that, which is the y-coordinate, would be negative 1. For B, we want cosine of negative pi, which is negative 180. Cosine, negative 180 degrees. A negative angle is going in this direction, which is landing exactly on pi. And cosine is my x-coordinate, so that answer also is negative 1. For C, we want to do sine of 390. Well, how much past 390 from the whole circle 360 is that? So if I do 390 minus the 360, I get that to be 30 degrees. Here's 30 degrees, and sine is your y-coordinate, so that answer is a half. All right, last one, tan, 19 pi divided by 6. So if I want to figure out what that is in degrees, I do 19 times, remember pi is 180, divided by 6, and I get it to be 570 degrees. So how much past 360 is 570? So 570 minus 360 is 210 degrees. So it's landing here. Tangent is taking the y and dividing it by the x. So I am going to be taking negative 1/2 and dividing it by the x. I wrote them down, I copied, changed it to multiplication, flipping this around. The 2's cancel. I get negative 1 over root 3, and then I rationalize this. So my answer for D is negative root 3 over 3. All right, looking at number 4, converting things to radians. To convert anything to a radian, you want to divide it by 180 degrees, then press math on your calculator and change it to a fraction, enter. And when I do that, I get it to be 8/5. You just need to make sure that you insert pi there, so it's 8 pi over 5. 120 degrees is actually on the unit circle, but if you didn't know, you do 120 over 180. Again, enter, math frac, enter, and we get it to be 2/3, so it's 2 pi over 3. And then for 36 degrees, I divide it by 180. Again, math frac, enter, and I get it to be 1/5 or pi over 5. All right, to convert to degrees, all I need to do is replace pi with 180 degrees in all 3 of these and work it out on my calculator. And when I do that, these are the 3 answers that I get for A, B, and C. All right, number 6, name the quadrant in which angle theta lies. So you need to remember quadrant 1 is here, and then it goes counterclockwise. Everything is positive in quadrant 1. Sine and its reciprocal is positive here. Tangent and cotangent. And this one is cosine and its reciprocal here. So when sine is, here's the symbol, it means less than, and cosine is greater than. So where is cosine positive? That looks like it's quadrant 4. Yep, and sine is negative there. So it's quadrant 4 for A. For B, when cosine is less than 0, and at the same time tangent is greater than 0. So where is tangent positive? That looks like it's quadrant 3. Yep, quadrant 3. And this was that thing from number 2, AST state. All students take calculus. All right, 7 and 8. Here are ones that we have to make a locate quadrant. make a triangle, label the triangle correctly with the trig function given, and then find the missing side. And then we're going to find all remaining trig functions. So let's figure out. It's saying cosine is, this angle is -1/3, so cosine is negative. And where is this angle laying? It actually tells us 90 degrees and 180, so that's quadrant 2. So I am sketching this triangle in quadrant 2, which is here. You always want to make your triangle towards the x-axis. So I'm going to go straight down and put my right angle towards the x. And we need to label it with cosine. So here, remember cosine, back from algebra 2 or geometry, was the adjacent side divided by hypotenuse side. So what's adjacent to this theta? It's right here. Where's the hypotenuse? Right opposite the right angle, so that's 3. We need to figure out the third side, so I'm going to use Pythagoras. And I'm going to work it out. This is 1. So I'm getting to be square root of 8 as the third side. All right, now I need to use these 3 numbers to figure out these 5 trig functions on the right. So the first one that I put there is secant, which is the reciprocal of cosine. So all I'm doing is flipping -1/3, which would be -3. Sine, if I look at the triangle, sine of an angle is opposite over hypotenuse. So the opposite side is √8. The hypotenuse is 3. Let's go to tangent real quick. So we get that one done. Tangent is opposite divided by adjacent. So opposite is √8 divided by -1. Now I need to do the reciprocal for sine, which is that cosecant one. So how do I do the reciprocal of 8 over √3? I flip it around, rationalize. So I'm getting at 3 √8 divided by 8. And then for cotangent, I'm going to flip around √8 over -1. And again, I'm going to rationalize. So I get -√8 over 8 for cotangent. All right, same for number 8. See if you can figure out which quadrant this lies in. Cosine, again, is negative, and tangent is positive. Okay, so that would be quadrant 3, because everything is positive for tangent in quadrant 3. I just sketched the triangle, and if you notice, I'm still making it with the x-axis, so I went up, so this right triangle is upside down. Again, I need to figure out the placement of the adjacent and the hypotenuse side, the -1 and the 4. So here's my adjacent side, here's my hypotenuse side. Use Pythagoras to get that third side. Okay, so this third side is √15. Common mistake is to forget about this negative, but this is a negative part of my y-axis down here, so that should have a negative on it. All right, now we got to find the rest of the trig functions. All right, so let's do the reciprocal first of cosine, which is CES, secant. So let's flip -1/4 around, so that would be 4 over -1 or -4. Let's do sine, and remember sine of an angle is opposite over hypotenuse. So what's opposite of that angle is -√15. Hypotenuse is 4. Let's go ahead and do tangent. Tangent is opposite over adjacent. The opposite side again is -√15 over -1. So that makes it positive √15. And now let's get the reciprocal of sine, which is CSC, cosecant. So let's flip that around. The reciprocal, rationalize. So I'm getting it to be -4 √15 over 15. And the same thing for cotangent. We'll flip cotangent around, which will make it 1 over √15. Rationalize. And I get it to be √15 over 15. Okay, now we are on to graphing ones. All right, so they have that same standard equation. Here's for sine. And I gave you different formulas for each of these things. All right, so looking at this one here, a sine 3x minus 1. Amplitude is the a, which is 3. period is taking 360 and dividing it by the B, which is 3. So that comes out to be 120 for my period. That's how long it takes to make one cycle of this graph. There is no phase shift because there is no C, so this is none. And the vertical shift is -1. That means it's down 1. Okay, so when we are doing these graphs, we need to have 5 points. All right, our starting point is our phase shift if we have. If we don't have any phase shift, then we're starting at 0. Then we're going to have 2, 3, and 4 in the middle. And then the last point, number 5, is going to be the phase shift plus the period. So I like to get 1 and 5 first and then figure out 2, 3, and 4 in the middle. And I kind of separate things. I go by 2s here. So I'm going to have it 1, 2, 3, 4, and 5. Okay, so my starting point. There is no phase shift, so it is starting right here at the origin at 0. My ending point is my phase shift, which I didn't have anything, plus my period is 120. So my ending point, my 5th point, which is the 5th tick mark, is going to be 120. How do I get in between that? Well, that's pretty obvious. Half of 120 is 60. Get in between 60 and 0 degrees is 30. And then between 60 and 120 is 90. The amplitude goes up to 3, 1, 2, 3, down to -3. But there is a vertical shift, so I need to consider that. So it is shifting down 1, so I'm going to put an imaginary, and I'm doing this in green, colored line. So I'm actually going to be going up for my amplitude 1, 2, actually it's going to be here, because I'm starting below where that green line is. And then my negative amplitude 1, 2, 3 is going to be down here. So let's plot the points first. So for sine graphs, you always are starting on the x-axis, sine graphs. The shape, general shape is looking like this. So here I got a big point at 0. Then at 30 degrees, oh, I did that wrong. Hold on. I'm going to erase everything here. Okay, my bad. So I erased that. Sorry, guys. I need to start on my vertical shift. So I am actually putting my first point here. This is my new x-axis, so it's right here. At 30 degrees, it's going to go up to the high amplitude. Again, remember, it wasn't here. It was right here, 1, 2, 3. So at 30 degrees, that's my high amplitude. Then it's going back to this x-axis, even though it's not, but it was vertical shifting down. Then it's going to go below for the lower amplitude for 90, which is right here. And then it's going to go back to the x-axis or that vertical shift there. So this is my sine graph for number 9, this is. All right, for number 10 here, we have a cosine graph. I have things labeled already, A cosine bx plus c, there is no d. And I circled -2 because it's a negative the amplitude, so that means when I graph this, it's going to be reflecting the opposite way through the x-axis. So let's get our things here. Our amplitude here is 2. Our period is 360 divided by the b, which is 3. So my period is, again, 120. My phase shift, I do have a phase shift. I'm taking my c, which is 90 degrees, but the formula says -c, so I'm going to make it -90 over b, which is 3. So that comes out to be -30. And there is no vertical shift. This is none. All right, so let's get our starting point. So our starting point is our phase shift. So we do have a phase shift here. So our first point is going to be at -30. Our ending point, our 5th point, is going to be the phase shift plus the period. So I'm doing -30 plus my period of 120, which comes out to 90 degrees. So it's going to be starting at -30. So I'm going to be on the left side of this y-axis here. So I'm going to go 2 boxes to the left of this origin. So I'm going to pretend that's -30. Let's go every 2 boxes. 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, and one more, make it 5. So this is -30. My last 5th line tick mark is that 5th point, which is 90. Now I got to find, well, what's in the middle between negative 30 and 90? You got to think about it. It is 30 degrees. 0 is in between those two, and 60 is in between them. Now, here I have my regular cosine graph I'm showing you here. It looks more like a U, and it's starting from the amplitude. But because of the reflection, it is going to be going the opposite way. So, all right, so my first point is going to be at negative 30, but it's going to be reflected on the x, so it's going to be actually right down here. Then it's going to be going up to the x-axis. Then it's going to the higher amplitude at 2 for 30, then back to the x-axis for 60, and then back down here 90 to the negative 2. So this is my cosine graph. Okay, for 11 and 12, we're going to be looking at trig identities. I put the trig identities to the right-hand side. We need to figure out which ones we're going to use, and I always say replace everything with sine and cosine all the time here. So for this first one here, sine theta, we're just going to leave it. What can I replace cotangent theta with? Well, I don't want this one. This is the one that I want because I want always cosine and sine. So let's go ahead and replace it with that. Tangent, I'm going to replace with this one, sine over cosine. And then secant, I'm replacing it with 1 over cosine. So if you notice here, now I need to evaluate things on both sides. Here I'm going to distribute this inside. And when I do that, you should notice that what is going to cancel here, but sines here. And we're going to be left with 1 times cosine, so that's just cosine theta. For this second part here, I am left with sine times sine, which is sine squared theta, over 1 times cosine is cosine. And this just keeps coming down on the right. Now, I can't add these two together because the first fraction doesn't have a denominator like the second one. So we need to multiply this by that cosine that the second fraction has. So remember, what you do to the top of a fraction, you do to the bottom. I don't need to touch the second fraction. So cosine times cosine is cosine squared. Over now I have cosine on the bottom. The second fraction is going to come down now. And so is that last one. Okay, so now I am adding them together. I got cosine squared theta plus sine squared theta over cosine theta, because that's the denominator, to equal 1 over cosine. Well, the bottom's the same. Does the top the same? So let's look at the identities. What's cosine squared plus sine squared? If you notice here, it is equal to 1. So this is definitely correct. We just proved the identity by making both sides equal. Okay, let's move on to number 12 here. Again, replacing everything with sine and cosine. So when I did that there, I have subtraction on the left and multiplication on the right. Well, let's do the right. That's easier. Cosine times cosine is cosine squared. 1 times sine is sine. Now, again, same concept. I can't subtract these fractions unless I have a common denominator. So I need to multiply this second fraction by sine because that's what the first fraction had. So what do I do to the top? I do to the bottom. So this first one is coming down. Minus sine times sine is sine squared. And the bottom is 1 times sine, which is sine theta. So now if you take a look, the denominators are the same. Let's bring it out. And now I'm doing 1 minus sine squared. Can't subtract two things that are different. And that right-hand side comes down. So the bottom's the same. How about the top? So let's look at our identities. 1 minus sine squared theta is cosine squared theta. So this is definitely equal. So we proved this identity. All right, last question here, 14. The following point, I don't know why it went on to the next line. A is negative 1/2 comma root 3 is on the unit circle. Find all 6 trig functions. Make sure you rationalize. So for this one here, we already know that cosine is my x, sine is my y, tangent is my y over x, and then we could get the reciprocals of those. So let's get these three first. Cosine is negative 1/2, so let's put that in there. Sine is the y, which is root 3. Tangent is taking the y and dividing it by the x. I wrote it. Now I'm going to do copy dot flipping. So I get it to be 2 root 3 over -1, or negative 2 root 3. Let's do the reciprocal of sine, which is this one, cosecant, this one. So I'm going to flip root 3, which would be 1 over root 3. And now I rationalize this. So I have it as root 3 over 3. Let's do the reciprocal of cosine, which is the secant, SEC. The reciprocal of -1/2, that's easy, is -2. And now I'm going to do the reciprocal of cotangent, which is the reciprocal, of tangent. So let's flip -2 root 3 over. So it's going to be 1 over -2 root 3. Now, all I need to do to rationalize this one is multiply it by root 3. Doesn't matter that 2 is an integer in the denominator, that's allowed. Multiply across, root 3. On the bottom, be careful, I got -2 times 3, because root 3 times root 3 is 3. So I have root 3 over -6. All right, so those are the problems that I selected. Hopefully this helps you out as you study for the test.